Hello scholars, welcome. Mr. Hinkle here. Let's talk about the hazards that are associated with earthquakes. An earthquake is a sudden burst of energy released in Earth's crust when movement along a fault happens. And that burst of energy travels through the interior and along the surface of Earth. Now, surface waves, surface seismic waves, are not what cause a loss of life. But the surface waves that shake the ground and shake the buildings and create tsunamis and landslides and all these other things, this is how we end up getting to fatalities. So let's talk about these. Earthquakes don't kill people, buildings do. Earthquakes shake the earth. The shaking leads to property damage, loss of life, and how much shaking is going to be determined by how much energy is released. We measure the energy released through magnitude, and then we assess the damage for how much shaking has occurred through intensity. What determines shaking and destruction? Well, it's going to be the type of building materials that are used. The flexibility of a building material determines its resistance to earthquake damage. How intense is the earthquake? The more shaking and also how long it takes, the greater the destruction is going to be. And then also, what is the resonance, the wave frequency of the seismic wave relative to the building materials? So if earthquakes don't kill people, buildings do, then what are the properties of the building to resist the shaking that is occurring from the earthquake? So first and foremost, shaking of buildings. This is our primary hazard. And then we've got secondary hazards. The shaking can lead to what's called liquefaction. And it's basically where you have unconsolidated sediments with moisture in them that buildings are built on top of. And when the earth shakes, these sediments turn into a wet slurry that can topple buildings. So we see the figure, stable soil, liquefied soil, the building tips. These are 4-story buildings that actually were built on top of soft sediments that tilted and toppled right over. So liquefaction, this is actually a thing. So if you are an engineer or a designer or planning on putting buildings, build your buildings on solid rock, not on soft sand. Tsunamis, this happens out in the ocean. Tsunamis are earthquake-induced waves that can completely wipe out coastal communities. This was the cause of the widespread death and destruction of the 2004 Sumatra earthquake. Basically, there's movement out in the ocean, a great volume of ocean water is displaced, and then that tsunami wave propagates and grows really large when it intersects with continents. So tsunamis, whoa. Tsunami is actually a Japanese word for harbor wave because the Japanese islands sit along a convergent plate tectonic boundary that has a lot of earthquakes and tsunamis. Smaller but still equally damaging, we've got landslides, seiches, which are basically tsunamis in lakes, but they're much smaller, and then ground displacement. So the ground can actually move like the Alaskan earthquake of 1960, where the road basically dropped down 10 feet, pretty wild. How do we know where the dangerous areas are? Well, we can create shake maps. So here's a shake map for the Morgan Hill earthquake showing where the epicenter was and the intensity using the modified Mercalli intensity scale of shaking. So if we can produce these relatively quickly after an earthquake occurs, then emergency personnel know where to go provide support and aid, and then also other types of workers can find damaged gas lines, utility lines, other facilities that might need to be repaired as quickly as possible. We can also say, given the structure of our Earth and where we know the faults are, where might we expect the most shaking to occur should an earthquake happen? Because earthquake prediction is still an area of improvement. We cannot say when and where and how big an earthquake is going to be, but we can say what is the recurrence interval of earthquakes, and what we definitely can say is that there will be more earthquakes, because as long as the surface of the Earth is actively moving, plate tectonics, earthquakes are going to happen. So shaking is our primary hazard of earthquakes with multiple secondary hazards. The seismic energy isn't necessarily what is causing fatalities and loss of life, but the destruction of buildings where people live directly leads to fatalities. So thank you so much, and I'll see you again.